OSPF, DR, and BDR election. DR and BDR election is done via the hello protocol. Hello packets are exchanged via IP multicast packets on each segment. The router with the highest priority, with the highest OSPF priority on a segment will become the DR for that segment. The same process is repeated for the BDR. In case of a tie, the router with the highest router ID will win. The default for the interface OSPF priority is 1. Remember that the DR and BDR concepts are per multi-access segment, not, of course, not applicable for a point-to-point network. Setting the OSPF priority on an interface is done using the IP OSPF priority value interface command. Actually gonna remove this because YouTube doesn't like it. Doesn't like that character. Let me just plug in my, okay, it's charging. All right, a priority value of 0 indicates an interface which is not to be elected as DR or BDR. The state of the interface with priority 0 will be DROTHER. Okay, I'm actually going to use this topology here. But one thing I want to say is that why OSPF uses DR and BDR concepts. So based on my understanding, OSPF uses it because if we have this kind of topology, all routers will become neighbors. So you have a lot of neighbors. So that's not very efficient actually. So that's why we have this DR and BDR so that uh, not all routers will become neighbors. And this is just this is just 3 routers. So um, if you have more than 3 routers, then excuse me, then you have a lot of neighborships. All right, so I have already configured the routers, and I can just show you the OSPF configurations. OSPF. That's the configuration on the OSPF configuration on R1. So as you can see, we are using this subnet. And let me actually, oops, say that R1 is .1, R2 is .2, R3 is .3. Okay, so next, checking the config still, just copy and paste it. I mean the config, OSPF config. So, all right, so same config on all the routers because they are on the same segment. Let me actually check OSPF. Oh, nothing here. Yeah, because the subnet is actually installed using the connected route. Should be the same on all the routers. Yeah. But let's check the OSPF neighborships between those routers. Okay. IP OSPF. Okay, let's start with R1. All right, so we see that in the output of this command, we see that R2 is BDR, backup designated router. R3 is the designated or a designated router. And on R2, R1 is DROTHER. So R1 is either a BDR or a DR. So it's called DROTHER. And R3 is, excuse me, is DR. And also, also also R1 sees R3 is the DR as well. And on R3, R1 is DROTHER, same on R2. Okay, yeah. And R2 is BDR. All right, so this is the election is actually done by default. So, and it says here that the router with the highest OSPF priority on a segment will become the DR for that segment. And if that's in case of a tie, the router with the highest router ID will win. So that's why router 3 is actually the DR because it has the highest IP address in this case. So if there's no, I mean, yeah, that's the router ID that's used because um, uh, there's no custom router ID because we can also do that as well, specify the router ID, and we can verify that by doing this command here. This is the router ID, and I can also do the same on R2. This is the router ID, and this is the router ID of R1. Okay, so we can actually uh, set the priority on an interface using this command here. Let's actually check the priority of an interface now. So the interface is gig01 on R1. See if we can find the priority here. It's here, priority. And we'll add this command to our verification commands. And this should be the same on all the routers. Oops. R2, okay, yeah, should be that interface. It's here. Priority, this one. So it says here um, default priority on for the interface is 1. So that's correct. And OSPF, what's the interface? Should be 0/3. Yes. So priority is 1. So I'm going to R1 and I will actually configure or make the priority on that interface on gig 0/1 interface higher than 1. So the R1 will become the BDR. Sorry, the DR. So I'm going to let me just type it. So IP OSPF priority. I'll make it 200. Just 100. Let's change this. And that will not change that will not take effect unless you actually clear the Ospf process. So we see that R3 is still uh, a DR here. So I'm going to actually just clear the process on R1 and on R3. So that will cause the neighborships to go down. It says, yeah, it says go down. And this is R2 and this is R3. Let's now check the neighborships. Okay, it's still doing its thing. So two-way, rather, yeah, still establishing. Let's give it a minute or a few seconds. Let's go to R3. Oh, all right, so loading to full, okay. This is R2, this is R1, all right. So now we can check. All right, so now we see, oh, DR, that's weird. Hold on. How come the R2, go to R2. R2. Its priority should be 1. So that's not correct. Let me just clear the process on R1 again. Oh, it's not, did I clear it? Yeah, so R1, hold on. Yeah, R1 has a priority of 100, but it didn't uh, become a DR. So I just clear the process, the OSP process again on R1. And let's now check. R1 became DROTHER. That's weird. Um, something else. Let me do it again. Let me clear the process on R2. Let me do it on all the routers. Ospf neighbor. Yeah, so looks like the election process happens, of course, when whether the router is up or not, right? I mean the yeah, the neighborship is up or not. So that's something that you have to also take into account. But looks like I mean R1 has become the DR now. Yeah, so now R1 is DR based on this output, and R3 is the BDR. So R2 should be the DROTHER. Yeah, R2 DROTHER. Let's go to R3. Yeah, so now R1 is also the DR on R3, and R2 is the DROTHER. And of course, um, I got this, I got this from this website. References. Refer. So that's actually how OSPF, DR, BDR, and DROTHER works. So yeah, that's all in this video. Thanks for watching.